Yeah, my name is René Groeschke. I'm working for Gradleware as a principal engineer, as I guess more or less everybody at Gradleware does, doing consulting, trainings, and spend most of my time on the Gradle code base. So what was the motivation of that talk? In the last couple of years, I was at different clients and I wrote plenty of release plugins that deal with releasing your software. And people start asking, is there something like the Maven release plugin? Anybody use the Maven release plugin before? Yeah, so you know what I'm talking about. And there are some plugins out there who cover some similar functionality or try to model exactly the same stuff. But this talk is not that deep about how to use some plugin. It's more about how simple it is to create or to model the release-related stuff you need to do with Gradle. And it's really easy to start doing that and apply your custom things you need to do during a release. So what I mean by release-related issues, what I mean is, essentially, I mean, what do you need to do when you do a release compared to, let's say, just a dev build, a local one? It's basically somehow you need to deal with your project version. Often, it depends a bit, of course. Often, usually you deal with your VCS. You want to create text branches, stuff like this. Of course, you want to publish, deploy your application or the distribution you just built. Usually when you do a release, I hope you have something like an issue tracker and not Excel files. I saw that too. The good thing about Excel files is you can use CSV format. So it's fairly easy to integrate in the build, but anyhow. I have that bullet here, double check your dependencies. What I mean by that is, especially if you build just a library or something and you need to make sure that your transitive dependencies are modeled correctly. And usually you don't want to release a library that depends on, let's say, a snapshot version or range of versions. Usually you want to lock it down. I guess Justin has more to say about locking down dependencies in his talk. Yeah, double check that talk. I'm not covering that at all. Just want to raise it here. And if something went wrong in your build, unexpected things, you want to see how, or you might want to roll back some stuff during your Gradle build. We take a short look on that too. I wondered if it's necessary to have a motivation video for you in place. What happens when you're releasing manually? So this poor woman, anybody knows that already? Yeah. Okay, for those who don't. Well, the idea is that if you release manually, you have all the steps listed in your, I guess, your wiki page or something. Who has a wiki page about deployment? Oh, not that much that I expect. Okay, so the idea is, the problem with releasing manually is that you might do a good job 4 times, 5 times, whatever, but you fail on the 6th time something. You forgot something to do, you don't export the right version, whatever. And what happens is something like this. She succeeded 2 times to use that slingshot for watermelon, but the problem is, at one point in time, you might feel way much pain. When you're doing a release. Yeah, and instead of looking like this, when it comes to the release day, I guess you should look more like this, like Fuzzy Bear, right? And well, what I learned earlier when we introduced Scrum in my former company, and the Scrum Master always told us, if a release is painful, just do it more often. I think that's generally good advice, that you should release more often to reduce the pain you have in your build. Okay, I have a small demo app which I use for my demos. There's a library called libgdx, which is some sort of 3D engine thing to build cross-platform games. Let me just, it doesn't really matter what that stuff does because we're more interested in the build. But just to give you an idea, it's something like this. I modified it a bit to collect Gradle coins here, but yeah, it doesn't matter. It's just simple app, so we don't care about this. We're more interested in the build file. Basically, it's taken from a sample directory from this libgdx guys. I have a link later on, and they support desktop apps, HTML apps, iOS, and Android. So it's pretty straightforward build. You have use some custom plugins here with the old or the current plugin architecture here. I extracted the release related stuff I'm going to demo in another Gradle file, whatever, and there are some customization for the desktop project and the other stuff. Just to give you an overview. So the first thing I want to talk about is project versioning. If you take a look at the first Gradle sample Java build snippets, you see something like this here. Version is 1.1 snapshot or whatever. Who uses it in that way? Hard-coded? Okay. Well, the problem with this is if you want to automate anything in your build, it's really hard to change that automatically. If you use that hard-coded snippet here, you would need to edit your build.gradle file in some dynamic fashion. I guess it's quite tricky. A better way to do it is to extract the version information in a separate file. So for example, you can put it in the version.txt file. And the nice thing about Groovy is that reading a file is that simple. So you just read that file, give the text property, which is the content, and you have the version information in your build or in your Gradle build. And this way, you have a dedicated file to log your versions you're using. It's way simpler to manipulate. You just create the file, write into that, and you're done, right? It's not just reading as a one-liner, writing to it is more or less two. So one other thing, okay, that's a good start. But you might have I don't know how your release process looks like, but you usually have some semantics in your build, how you release. Maybe you base your release on the branch you're currently working on, so you have your version has, I hope so, some semantics in it, so what that version means. So in this case, what I did is, instead of just using a string or an integer, I use a custom class I implemented. Here it's class myVersion with 4 fields, major, minor, bug fix, and a build number, let's say. And you just need to override this toString method here. So, and you can now assign that version property in Gradle can be anything, can be any object. And internally, when we write, let's say, deployment descriptors or stuff like this, the toString method gets called. So I combined the stuff we used before. I have a version property files with information about that version. And I just create this class out of it here. Yeah, let's go to the first demo. So what I want to do is I want to be able to run, or I want to decide on release. When triggering a release, I want to decide if I want to do a major, a minor, or bug fix release. Let's see how I solve that. So here we have this version class I just showed you more or less, but with some implementation details. So there's a snapshot flag, so I don't use a build number here. I use Maven snapshot theme here, and there's a load method implemented, which basically takes a version file, and the version file is a .properties file. And what I do is I pass the information out of that and create a new instance of that version class. So here's a toString method. It's quite similar what you saw on the slide. But what I added if the snapshot flag is true, I append the snapshot statement. Otherwise, I don't. Pretty straightforward. And apart from loading a version, I implemented a method just for storing the version information. Here, just create the properties and write that to the file. That's simple with Groovy. So here we are. We save the bug fix, the major and the minor information, and store that in a property file. What I added next to that version class is that I added the logic to how to calculate the next version out of it in that class. So I added a method called next, and what it does is, depending on the release type, which can be bug fix, major, minor, I create a new version instance out of that. Nothing surprising things here. Just increment the major version if I create a new major version, and the minor stuff is the same. I create a new version with the incremented minor value and reset the bug fix to 0. So how do I use that in my project? What I did here is I store the information what the latest release was in a property file. So I have a latest.property file where I put the version information about the last release I did. You can read that from a property file. You can also, like what we do in Gradle when we release Gradle, since we store our versions in S3, we have the metadata file where we store that information. So you don't really need to put that in your VCS. You can put it, you can gather it from anywhere, maybe from your Artifactory if you want to, something like this. So, and what I did then, after I have my latest release version, I just say that the current version I'm working on is the next of that. And as a default, I make a bug fix release, or the bug fix version is the next one. So if I have 1.0.0, latest.next would give me 1.0.1. So here I have a release task that does currently nothing. So if I build that stuff, and now if I go and let me show what that build did, it builds a snapshot version. Yeah, straightforward, I guess. The problem is now so let's take a look here. So there's this bug fix major minor property file. The problem is if I do if I do a release now, nothing changed. That looks a bit suspicious. So what I wanted when I do a release, don't want to do a snapshot, right? I want to do a plain release without that snapshot flag. So let's see how we can do that. Just to make sure, just to be sure here, we don't have that release. So what's the best place in a Gradle build to make that decision? And I think the best place is what you can do in Gradle. Maybe some of you are aware of that. You can trigger the task graph. So you can ask Gradle which tasks are involved in that process. So when you trigger a build, there are these three phases, right? So first the configuration is done, and then Gradle builds this task graph, which contains all the tasks that you will execute during that build. And with that, when ready hook here, you can just query that graph and figure out if, for example, the release task is part of it. So let's flip that around. So I want to do if my current Gradle invocation contains a release task. Quite simple. Since version is now my typed class, I can just set the snapshot flag to false. Let's do the release here. And if we look into that directory, yeah, it contains a 1.1.2 version without a snapshot in it. Okay, good. So next thing is we need to decide, or we need to persist the version information. What I do here, that's simple. As a first step, I just write to that file. I use that store method I implemented. So I create a task, persist version info, and I said, okay, the release depends on that persist version info task. Pretty simple. And now when I run a release, I know that the latest of properties contains this fixed or this updated information. So the problem now is that I still don't know if I don't have modeled yet if I do a major, a minor, or bug fix release. So how can we do that? So where's the place to model that? Since we just have 45 minutes again, you could model that in a plugin, stuff like this. I kept it simple for this demo. So you already have this next class or next method on your version class that can deal with different release types. So we just need to figure out how to use that. So we need to model the type of the release somewhere in our build. And I guess the best place for now is to put that into that release task. So at the moment it's just a default task. So what we can do is we can make a type task out of that. And in that type task, let's add the property and call it type. We can be, I haven't found a better name. I could have, but. And the default is bug fix, and let's add some default action there too. So just to make sure that we did something, we had the print line statement where we just print out doing a release with the type of the release we're doing and the current version information. And if you go back, here we see doing a bug fix release of 1.1.4. That's the default setting. But now we need to figure out how to pass the information about major, minor bug fix, so of this type. Well, I guess there are plenty of solutions out there. One might be you want to have different release tasks, one for major, one for minor, one for bug fix. So something like this. I'm not really a fan of this, so let's use something else. One way to do it is to just pass a system property. A nice thing about system properties is that they are widely supported by Jenkins or whatever CI server you use. You can pass system properties that simple to your build. And with your CI, I guess you have some nice UI to model it, stuff like this. Now I passed nothing, okay. So, but let me show you an alternative way. So we are currently working on, we start working on adding some features to make it easier to pass properties from the command line. At the moment, you just have the option to pass system properties or to pass project properties with the -p command. In the future, there will be some sort of, that you can have first level support for flags. Let me show you how that would look like. So I import an internal class for now because it's not yet public. So there's an annotation out there called Gradle API internal task options option. So this will be part of some of the next releases, I guess. So we just annotate the field you want to modify, and you give it a description. First you give it a name. Let's use the same one as a field, so type, and you can add some meaningful description to it. Yeah, something better than the type of the release, maybe, for your production. But that's it. And now on your command line, you can just trigger this Gradle help, passing the task. And as you can see, this class has now options listed, --type, and the type of a release. If we would use enums, I haven't, you would see the optional or the available enums here, but yeah, you can play around with that already, but it's not yet part of the public API. Just need to fix some more stuff here. So if I run now a release task, I can just type --type and assign a major to it. Now I see I do a major release here. Well, actually, it's telling me I'm doing a major release, but I guess I don't really. The problem is I don't reflect the pass property to the version information. So that should be an easy fix. So here type is default bug fix. So what we can do is in the task graph when ready, we can say, okay, if you're doing a release, give me the next based on that property on that release task. And now, if I run the release again with type major, yeah, that's a major release. I do a 2.0.0 release, and here I have the stored information, bug fix 0, major 2, stuff like this. Okay, so that was a first demo. The next topic I want to cover is dealing with your VCS. There are plenty of plugins out there already to deal with Git, with SVN. Anybody using ClearCase? I haven't seen an open source ClearCase plugin yet, but I guess for a reason. So in this example, I use Andrew Oberstar's plugin. He wrote a Gradle Git plugin. And well, it's pretty straightforward. The same way you use usually all the plugins. What you do is you apply the build script block where you reference the Gradle or the plugin you want to use. Here you need some sort of initialization. That might be, currently that should, I think it should live in a plugin, right? So you need to do that manually. Usually you want to apply Git plugin, something like this. But that's how it works at the moment. And then you can use that stuff after it's initialized. You can do releases or tags, sorry, create tags, branches, whatever. The problem is if you find a good one, I guess the Gradle Git one is from Andrew is quite okay. The problem is that often they are some sort of opinionized, so they might do almost what you need, but sometimes they miss some features and you need to hack around. And then it might be easier for you to fall back on things Gradle offers out of the box, like the exec task. So you can, if you're sure that Git is installed on your environment where you do your VCS sort of stuff, you can just use the exec command or the exec task here, which which just offers you a way to reach out to external tools. So you just configure a command line here. I say git tag and then pass the project version here. So I created tag with just 3 lines of code. And compared to that, it sounds a bit simpler. And if you're really familiar with the Gradle DSL and use the exec task for other stuff, it's that simple to do, I think. A minor side note, Git is really, the nice thing about Git is that you can actually, if you need the commit ID, to some degree it's possible to read that with just file operations. You don't need a Git Java plugin or Java library, or you don't really need Git installed on your system. To some degree, you can do quite a lot of stuff without the Git commands, because the way Gradle or Git is written with a .git repository, it's really worth to have a look what you can do with that. So next puzzle. So what I haven't talked about when doing when dealing with a VCS is at one client there was this release engineer, and he don't trusted any developer. So, and what he wanted to have is, he wanted to make sure that when you do a release on the clean copy, that you haven't touched any files, so that you can always reproduce a release based on what you checked out, because otherwise you can't, right? If somebody changed whatever, it's not reproducible for you. So let's have a look at how to integrate VCS support in our sample project. First thing I did is, you remember this persist version info task where I did this? Basically, I did this here. What I did now is I changed it to be an exec task, and as you can see, I saw the version information as I did before, but now as a main action, I commit that information right after I persisted, or I wrote that file with what you saw earlier: command line git commit -i latest properties, and then some message out there. And furthermore, okay, here that's what you saw earlier. My previous example. Come on. And here we have tag workspace, another task. Yeah, just 3 lines of code to tag your workspace. And what I did here is I let the release task depend on that tag workspace task. Let the other change. Let's take a look at how it works on the command line. So if I do Gradle release, you see I persist the version info. I take the workspace. So persist version info. And if I look at the tag was created correctly. So, and here's a commit for storing the version information. So the problem now is, now I have a polluted workspace somehow. Well, here's obvious, that's what I played for. So I changed some files in my local workspace, and I don't want, Gradle should not enable you to do a release on a polluted workspace. So what can you do about that? Well, you can just write another task, right? So you write check git workspace. Again, it's exec task. If you're using Git, if you're happy and using Git, it's quite simple. You just call git status, and then Git offers something called -- I don't know if I pronounce it correctly, porcelain. With that flag, it offers you some machine-readable friendly output. So basically, it means if you have a clean working copy, the output is empty. Otherwise, you get a nice view, as we will see later. So I just have this exec task, which does not, well, status does not fail, so we have to implement some check here. And what I do is, I just grab the standard output from that git status command. And in the do last block, let's give it a meaningful variable name, git status. And then I just put an assertion here that git status is an empty string. The nice thing about giving it a meaningful name here is when we run it from the command line, you will see that you get a meaningful message here too. That at the first glance, oh, of course. Yeah. What's wrong? On the first glance, you see what's wrong here. Git status is not empty, and it contains change, puzzle, and release. So, but there's another bigger issue with that. Well, that was quite simple, but what's the problem when you look at these task execution here? What might be the issue with that? Well, there are no tests, I guess. No, something else. I guess it would be more obvious if I have a real build with a lot of. Exactly. The problem here is I check this git status quite after the build. So if you do really a lot of stuff, like I hope you have plenty of integration tests and unit tests, the check git workspace task, which is quite cheap, just happens very late in the build. So you run the build for, I don't know how long it takes for you, an hour or so, and then somebody says, well, your git workspace is polluted. And that should be the very first task to do. What you could do is you could make the check git workspace task depending on all other ones, or change the other ones to say, well, must run after, stuff like this we just introduced. There's another, or I guess there are two options now to fix that in a better way. One thing is we could do it. We could use that logic and just put it again in a when ready hook. In my opinion, that's far away from being ideal. I think the when ready hook should be just used to set flags to do not really much work here, because the other thing you use or you lose when using that flag for doing that check is that you don't get a nice output. So this logic won't show up in your task graph and stuff like this. And if you want to figure out what happens, it's hard to trace that. So instead, just to give you an idea, what you can do in Gradle alternatively is you can check with what parameters Gradle was invoked. So you could just ask for the start parameters. So you can use Gradle.start parameters and ask for the task names. And if release was part of it, I changed that task names list to put something on the very first position. I thought it would be easier to do that by just saying tasknames.o is the new task, but actually it isn't, because I think it's a immutable list or something. So let's put check git workspace first and just put that here. So with that in place, if I run that, let's fix that typo. And if I run Gradle release now, again the same issue, but it fails on the very first task. So let's speed up things and fix that, commit that stuff. Commit that stuff and run it again. Okay, we are safe. And now Gradle release. And as you can see now, the build or the logic that contains your real build is put after the check task here. And then I do the take workspace, the release, what we saw earlier. Okay. How much time do I have? Oh. So the last demo I have prepared is working with your issue tracker. Usually even teams, what I saw is even teams that automated a lot of stuff, they don't think about their issue tracker. But it's really worth the effort to automate stuff with your issue tracker. It's really a safe way to keep your version state in sync from what you build, what you have in your issue tracker. It's really nice way to document the tackled issues and to check your project status. So if you don't want to release a project which has open blocker issues or stuff like this, that you can do with your issue tracker. One example, I guess, it's not really, but I guess most of you have seen the Gradle release notes. So for example, what we do is we query the Jira instance we're using for listing all the fixed issues. So it's not a manual process. And we have another logic to list well-known or known issues for release. And that's really easy to document. That way you can really easy document what you did during your release. If you just have maintained your issue tracker in a good way. So basically, if you want to connect your issue tracker, most of them have a huge API, which offers more of I ever thought of. The well-established ones like Jira, UTrack, Trello, or I don't know, anybody using GitHub, maybe for your open source project. They offer a really good integration. Usually all of them offer REST, so a REST interface to deal with it. And the nice thing about REST is that it's really easy to do in Groovy, and therefore it's really easy to do in Gradle to deal with REST. Sometimes I hear people saying, well, we have a custom tool. Maybe that's now your chance to get rid of it. The companies I visited, sometimes they had some own written issue tracker tool, but I never saw a compelling reason for that. But I don't know, maybe some of you have a compelling reason to have that. Does anybody have a? Okay, too shy. So let's take a last demo. Well, for this demo, I use a GitHub issue tracker because it's open source and easy to use. I changed my demo app. Instead of having just this check git workspace task, I now have a check issue tracker task. And I combined them in a pre-release check. So that task contains all the checks I want to do before doing a release, before running all that compiling test stuff. And I implement the check git workspace, check issue tracker task here. Let's take a look at my sample code. So what I can do now, if I run Gradle release, type major again, so I want to release version 3.0.0, let's say, I get an error now that tells me, well, you cannot release Gradle or release version 3.0.0 because you have unresolved issues. And if I take a look at my GitHub overview, that's slow. Maybe I see that later. So what I did is to implement this is I introduced a build source directory to put my classes there, because I already had this release task. I already have this custom semantic version class. And what I did is I created a build source directory. Any who's not aware of what build source directory is about, it's a way, if you have custom Gradle logic, so class files, stuff like this, you can put it in a dedicated project, which is named build source. And that one, when Gradle finds a directory named build source, it just tries to build that project, which can be, usually it's a Groovy project, or it can be a plain Java project, and puts the output of that directory on your Gradle task graph, or not Gradle task graph, on your Gradle class path, and makes the classes available in your Gradle build. So here I have this new class issue checker. I'm not good at names at all, so. And what I did for build source, the nice thing about using a build source directory is that it makes it quite simple to add ideas or IDE support for your Gradle logic. So if we go there, what I did is I added a custom build.gradle file here, and I applied the idea task. And then if you run now Gradle idea on the command line in that build source directory, you just get a valid idea project, which you can import in your IntelliJ. And that way, now you have full support in your IDE with all your code completion, whatever stuff. That's really nice. So that's how the issue tracker looks like. Basically, it has one task action that grabs the content of a URL. Again, as you can see here, that's the place of that class. So we have this build source project, which just looks like has the same layout as a usually Groovy project. So we put our sources in source main Groovy, package, and issue checker is a class name. And if we look at the code, it's really simple. With Groovy, grabbing some content from a URL is again just a one-liner. So this is all which is necessary to get the content of that URL above. And that gives me back a JSON string, which I now want to validate. And for that validation of that JSON string, I can use a JSON slurper, which is a library shipped in with Groovy, so you have that out of the box. And here I parse the JSON text, and I look for an entry of where the title is equal to my project version. So that's the title is what the meaningful name is in GitHub. And if that release is not null, here, if that release is not null, I double check that the state is still open so that I don't release something that I already closed. And what I also do is I check that the current release has 0 open issues. A nice thing about this exception is that I just created a meaningful URL in that exception. So here I calculate this URL based on that version I'm trying to release. And if you have a good operating system, you can just command click on it, and it will just offer you open your issue tracker. So that's my example release. I have milestone 3. I can see that I have 2 closed bugs and 1 open one. So that stops me from releasing. It's check filed issues against current version during the release process. So basically, that's what I just implemented. And I can mark this one as done. I should spend more time on preparing that. So just mark it, close it. Now no open issues, and I can see here a full green bar. So I'm ready to release. And if I'm now going back to my build, I can just run the release again. And I'm able to release the 3.0 version. Tagging, update issue, yeah. So I have this build source stuff, then I have the check task here. I build my stuff, run theoretical my tests, and here's a release. I'm doing the 3.0.0. What I added here is update issue tracker task. Scroll down, whatever. What I added is update issue tracker task. We haven't seen yet. What I do is after the release is done, so I trigger the release, I want to update my issue tracker. I use this finalize by block. Let's take a look at the implementation of that issue tracker task. So here, now I see what it did already. It closed my milestone, which is a release in GitHub. And here it was closed a minute ago when I just run the release. And it added some sort of description, nothing fancy. Released using Gradle release process. And if we look at the implementation for that, it's a bit more stuff. The main reason for that is I need to do more requests than once. First, I need to check out the ID of the issue. And then, since I'm not just reading anymore, I want to manipulate stuff. Yeah. I need to deal with authentication, which is sometimes the most, it's a bit an issue with REST. But after you have done this, you're pretty on a safe side. Two more slides, I guess, about publishing. Well, I won't talk about publishing because there are plenty of talks about publishing, doing with web stuff or with Docker or whatever. Basically, if you do a library, you have basic Maven repository, bin tray, or Maven Central as a target. That's offered out of the box. If you do S3, FTP, SSH, whatever, there are already custom Gradle tasks or plugins available to deal with that. If you haven't heard of LiveRebel, I have a demo for that. We can see that later on if you grab me at lunch or something. That's a nice tool with dealing with server-side applications, and you can manage different things like your testing environment and your production environment. Yeah, and I guess there are more tools out there. So the last thing we haven't covered is if something went wrong during your release. What you can do, well, I guess option one is not really an option, but that's the last thing I want to show you is even if the build already failed, your Gradle build, you have a hook available to add custom logic to that. So what I did here is in my build script or in my custom plugin, whatever, I add a build listener. And for example, I guess the guys who used Git already wondered, I haven't pushed anything, so it's not that safe so far, what I demoed. So what you can do here is, for example, if the build finished with a failure, I call a custom implementation of git reset, which does a reset of my current workspace. Or if anything went well, I just do a git push and push that to my main remote repository. That's the very last hook you have available in Gradle to deal with some sort of, if you want to clean up some stuff. General, what I want to mention here, there's a whole library about dealing with semantic versions. That's really worth to take a look at. The Gradle Git plugin does plenty of stuff more than just being a Git plugin. Yeah, Live Rebel I mentioned. And I guess we have almost no time for QA. Is there any questions left? Yeah?
The source code to your demos, are you posting that somewhere?
The source code, I make the slides available as a link or something on that Gradle Summit page or something.
Not there.
Sorry?
Not there.
Yeah, I will. Well, the problem is the format with HTML. Doesn't matter. I add that later on, and that contains a link to my demo app already. Yeah. Anything else? Yeah.
You mentioned publishing to Maven or S3. Is there any plans to look at Maven S3 writing for the Maven publishing plugin? I don't know.
You mean publishing to S3 and use S3 as sort of Maven repository?
Yeah.
Not that I'm aware of. Yeah. Anything else? Excellent. Have a nice lunch, I guess.